Hi, I'm Craig the Geologist, and welcome back to part 2 of this 4-part series identifying fossils at Rockport Quarry. Rockport is an old limestone quarry in Devonian rocks in northern Michigan, and it is one of the best places to find Devonian age fossils on the planet as far as I'm concerned. In the previous episode, we learned about the paleo environment here, the ancient Caribbean-style sea that existed in this place, full of corals and fish and exotic animals. We had a close-up look at crinoids and explored stromatoporoids and the reefs that they built. Let's begin this episode by going out to a preserved island, an ancient island where we can still find the ancient organisms that used to bury themselves in those sediments, brachiopods and bivalves, shelled clam-like organisms. Come join me as we learn more about our fossil treasures. We begin as we approach our preserved ancient island. As we make our way over here, we are getting shallower, not because there's an elevation change, but because we are approaching an ancient preserved island, which is crazy to me, considering the way erosion works and the millions of years involved. The fact that you can have an island that's preserved is just remarkable. But that's what you get over here. You can see it in the change in the rocks. The rocks go from featureless limestone, probably deeper deposited limestone, to more shaly stuff. But then over here, the nature of the rock changes entirely. You notice we're not seeing those nice rock faces anymore. You're still seeing it a little bit over here, and certainly over in that area pretty well. However, over here, it's a sandy slope. And that is not because a bunch of sand from the top of this hill fell into the quarry or because of anything the quarry operators did. This is sand over here. It's a very, very poorly consolidated sandstone. And not only do we see the change in sandstone, but we see a change in the fossils. Over here we see shallow clam-like organisms. Can't call them clams. A paleontologist goes nuts every time they hear someone describe brachiopods and these other species as clams. But to the layperson, they look like clams. They're shell fossils that you find in sandy beach type environments, and you get a lot of that here. I'm going to drop my backpack and let's explore it a little bit, see what we can find. There's been a lot of rain recently, so there might have been a lot of new stuff exposed. So we make our way up. Here's a broken side view of a beautiful Petoskey stone hexagonaria coral. Oh, what have we got here? Well, here we've got a shell fossil. What about that? That, my friends, is a trilobite, or at least it is the cast of a trilobite. Look at that. Now, I've always had a very difficult time identifying trilobites. In fact, I misidentified a trilobite out here once in a class, and once I corrected myself, she had already thrown it away, although admittedly she had dropped it during a medical episode. But she claimed I had destroyed her life and ruined rock hounding for her forever by misidentifying it. My apologies to her, but I think it was a little dramatic as well. How can we distinguish this from a shell? Because there are lobed shells. This is broken here. It would be perfect if this continued, but there's a section of shell here and then a little divot here and then an identical one over on this side. So there's two lobes and they're growing like that. Well, and you do get 3-lobed brachiopod shells too. They're less common, but you do get them. So how do I distinguish that? And it's not a full trilobite, obviously. It's the, I like to call it trilobut. The head is gone. But how do I see that and distinguish that from a brachiopod shell? Well, the easiest way, and this is something I hadn't picked up on for a long time, until relatively recently. A paleontologist probably learns this in their first week, but for a geologist who doesn't do paleontology much, this was kind of a revelation for me. But these striations, all right, these ridges, they're going, we'll call that horizontally. They're going horizontally with the body there. They're going widthwise. Whereas for the brachiopods, for the shells, they start at a point and grow outward vertically in the direction that they're growing. Now, fun fact, I tell people all the time that I have never found a trilobite fossil, even though I should have found several thousand by this point in my career. And maybe it's because I've been so bad at identifying them, although I don't think that's really been the case. I mean, I know I've been bad at identifying them, but I don't think that's the reason I haven't been finding them. But yeah, there we go. That's my first. I might take a rock hammer and try to break off some of the big stuff here so that I can just take the actual fossil trilobite part. And it's really not a very good trilobite fossil objectively. And so if it does break, it's not the end of the world. I've got it on film here. I've got proof that I did in fact find one. Let's see if I can give this gentle taps. There we go. Well, that's good enough for me. I'll just put that in my pocket. Let's keep looking. I thought I was going to be showing you all sorts of shells out here, but first thing I find is a trilobite. That seems unlikely. That's awesome. Here we go. Here's a lot of shells here. This is a worn away one. You're seeing some of the interior shell nacre. There's a brachiopod there. Now, what kind of a shelled fossil do we have here? Well, most of what we find out here are brachiopods and bivalves, with brachiopods being the dominant variety. But how can we tell the difference between a brachiopod and a bivalve? Well, that's a problem that plagues pretty much everyone who isn't a paleontologist or a geologist focusing on Devonian age rocks. The easiest way to distinguish bivalves from brachiopods by far is through their symmetry. Let's talk about clams for a moment just to really tick off the paleontologists. But think of a clam. It is composed of how many shells? 2 shells, a top and a bottom. There's probably a more scientific term for that, but as far as I'm concerned, a top and bottom shell. It's the same for all bivalves and all brachiopods. Now for a brachiopod, if you're looking at just the top shell or just the bottom shell, the left and right sides of that shell will be symmetric with one another. Left and right hand sides will be identical. The top and bottom shells, however, will not be symmetric with each other. They will not be identical. Bivalves, on the other hand, may have an asymmetric shell shape when looking from the top or bottom, but the top and bottom shells are symmetric with each other. They are identical, or at least they're chiral. They are the same shape insofar as they fit together perfectly. And so let's have a look at this guy. Is it a brachiopod? Well, I see a shell out here. I almost always call it a brachiopod because that's what most of them are. But what's the symmetry telling us? Well, we can't see the top and bottom shells, so we can't judge whether the top and bottom shells are symmetric with one another. But we can take a look at this top shell and see that it curves to the right. It is asymmetric through the top axis. That top shell, the left and right sides are not perfectly symmetric. It's warped, it's curved, and that tells us that what we're looking at is a bivalve. Now, can we get more detailed than that? Can we nail down the class, subclass, order, species of this bivalve? Well, somebody probably can, but I cannot. In fact, it's actually easier to see through my camera than with my naked eye, but there's a beautiful bryozoan fan here. This is unmistakably a bryozoan. And I say unmistakable, I mean unmistakable to a geologist, to the average rockhound who's just coming out looking for fossils for their first time, it's often mistaken for fish scales. But no, this is a fan bryozoan. Bryozoans, or bryozoa, pick your plural, are delicate moss animals. At least that's the term given to them. They tend to look like underwater plants and bushes or corals. They are not. They are living colonial organisms. They are tiny little organisms that build a large skeletal structure and inhabit tiny holes along that structure. Thousands upon thousands of them on each branching structure. And from inside those tiny little holes, they put out tentacles and fronds and catch passing food debris as it goes by and filter feed on that. Now, some of you might hear that description and think, well, you just described coral. Because what are coral? They are very frequently tiny colonial organisms, animals that build calcareous skeleton and create a larger structure and share it with their neighbors and live inside tiny holes in that structure and reach their tentacles and whatever parts out to catch passing food. Didn't I just say exactly that for bryozoans? Well, it's not your imagination. I did. Bryozoans and corals are actually very, very similar to each other, but they are distinguished a little bit based on how delicate the structures they make are, but more on their biology. Bryozoans have more complex digestive tracts. Corals have stinging tentacles, while bryozoans don't. Bryozoans just catch passing particles and move them into their mouths, and they put their tentacles out using water pressure to extend and retract them, whereas corals have stinging tentacles that stun prey and pull it into their mouths. Looking at the fossils though, because you obviously can't tell the internal biology of the individual organisms when you're looking at a fossil, you're going to tell the difference between coral and bryozoan from the size of the holes in it. The corallites in a coral tend to be about 1 millimeter or larger in diameter, whereas the zoetia, the holes that the bryozoan organisms live in on a larger colonial bryozoan, are tiny, always smaller than a millimeter. Now, the holes you're seeing in this fan-shaped bryozoan are not the zoetia. These are not the holes that the organisms lived in. These are actually holes through which water flowed. These fan-shaped bryozoans had this lattice work that allowed the water to flow through them. And you have to imagine that is mostly a structural benefit. A small amount of current brushing directly against a fan could knock it over. So having this fan that is made about 50% hole and 50% structure allows the water to pass through it and gives a lot less resistance, and it allows it to withstand currents much better. At the same time, those bryozoans that are living on it benefit because they can filter the water that's passing through those holes at the same time. Now, identifying the species is actually a little bit easy with a fan-shaped bryozoan to some degree. Now, the more common fan-shaped bryozoan in the Devonian period is Phenestella, and you see that all over the place, and you do see it a lot at Rockport as well. However, based on the look of this, it looks to be more of a polypora. Phenestella's branching network that creates the lattice work tends to be a bit coarser. The branches tend to be a little bit thicker and a little bit less regularly spaced, whereas polypora forms this sheet that looks like it's gone through an industrial hole punch. Now, Phenestella and polypora can look a bit similar, and they inhabited the exact same environments at the exact same time. Phenestella and polypora were neighbors in their environments. So this is definitely a polypora, unless a paleontologist weighs in and tells me I'm wrong, in which case it's definitely a Phenestella, unless they say it's something else. In all fairness, when you read through the detailed guidebooks, they'll list 25 or 30 similar looking bryozoans, frankly. But polypora and Phenestella are your most common ones, and I believe this is polypora. People often mistake these for being fish scales. They see this, they say, oh my gosh, I found fish scales. No, you didn't, but you found something just as cool, if not cooler, in fact. These Bryozoa are pretty awesome. Those are all fossil fragments in there, all fossil shells. But they're also very worn down. In fact, I don't think even a paleontologist could identify what those were because the identifying features are all worn away. We got some Bryozoans here. These are the stalk forming Bryozoans. More shells, a whole bunch of shells here. But again, very, very weathered. Let's see if we can do better. I'm sure we can. Let's go upslope a little bit, where stuff may have weathered out a little bit more recently. There you go. See how the left and right sides on this shell are symmetric? Boom, brachiopod. As for the species, it looks a lot like Trilobites to me. It's a widespread brachiopod in the Middle Devonian, and it's used as sort of a marker fossil for age dating rocks because it's very widespread at that time, but doesn't really appear anywhere else in the geologic history. It shows up very suddenly at the start of the Devonian and then disappears very suddenly as well, probably like humans are about to do. It's just a standalone shell just hanging out here. Over here we got Bryozoan, nope, shell fragment. Ooh, that's a pretty one. That's very fragmentary, but I bet that's got structures good enough for me to identify. Oh, and there's even a little piece of Bryozoan fragment up at the top here. So 2 fragments for 1. And no, that piece wasn't large enough for me to identify. It was just too small to get beyond the general classification of brachiopod. We got some stromatoporoid that fell down from above. We got a little crinoid stem. Oh, well, wasn't a very good one anyways. Not too many shells over here yet, but I do recall that some of the better ones were just over a little bit from where I'm at right now. Let's travel. All right, I haven't found anything yet, but I'm confident enough once I reach this area here that I will find something quickly, that I'm just gonna turn it on and we'll find it together. I won't stage anything for you here. I'm just gonna straight up look together. That is a piece of glacial debris that got dropped here. All right, Rockport, don't make me a liar. Where are your shells at? Here's one here, but again, it's pretty worn. So if all we end up is finding pieces like that today, I'll be a little disappointed. We ought to be able to find a lot better than that. Big fragment here. You can see the hinge right there. The rest of it got broken out. Must have been a pretty big guy hidden when it was intact. Actually, Well, I have a seat right here because I think we found a nice spot. So where am I sitting here? Well, I'm on a sandy slope on the side of Rockport Quarry. But where am I at really? Well, 390 million years ago, I am probably waist deep in beautiful Caribbean style waters. On a sandy beach nearby, we got fish swimming around, although you don't see very many fish fossils out here. You do get some. But I am in the sandy bit where, you can go clamming. I say that just to tick off my paleontologist friends because these aren't clams. But you can dig around and find all sorts of shelled organisms buried in the sand here. So let's take a look at what's under my butt. All right, here we go. Here's our first real nice one here. This is a brachiopod, and you can tell that by the fact that the left and right sides are symmetrical with one another. Now have a look at the very flat bottom of this. Yes, it is broken, but you can see that it doesn't really come down to a point. It would have come down to a very flat bottom. It is a scallop-like organism, and I believe this is Strophodonta. It does have similarities to Devonoconides. That's a fun one to say. And admittedly, a lot of these brachiopods can look very, very similar to each other. And even in the descriptions, there are very similar sounding named ones that appear with very small variations in their anatomy. They are almost identical, frankly, as far as our eyes can tell. So because I think this is a little bit too large to be Devonoconides, let's describe Strophodonta. Strophodonta was scallop-like. It didn't attach to anything. It tended to rest on the soft seafloor, and scientists believe that they flap their shells just like a scallop does. The scallop does it to move. I'm not sure if they know whether it did that for locomotion, but they think it definitely used that flapping motion to clear soft sediment from the inside of its shell and from its surface. All right, well, not far from it, we got this guy here. Oh, if I can grab the right one. This guy's a bit scarred up, but you can see the lobes on that still a little bit. And it's got these flared points at the end. That helps us identify it. This brachiopod is a little bit more worn away than I would have liked. It doesn't have the finely detailed ridges that would have been great to see in this specimen. However, the general shape is very, very distinctive. This is a Mucrospirifer. Now, like many brachiopod species, the name is a bit of a mouthful, but it actually makes sense when you understand the meaning, because Mucrospirifer means sharply pointed spine bearer. Now you can't really see a lot of spines on it, but you can see these points on the end. This very squat but very wide variety of brachiopod with ridges on either side and a deep groove in the middle, and especially spines on either side, that's Mucrospirifer. They're not rare, and they belong strictly to this time frame, the Middle Devonian. No earlier, no later. They showed up for a little while. They showed up everywhere in places like this and then disappeared entirely. The pointy bits at either end of their body are sometimes referred to, not just by lay people, but by scientists as wings. And they were designed to help with the filter feeding process. They would pull in water through one of the points and then filter the water through their body, collect all the food, and expel it from the other end. Their elongated shape stopped them from sinking into the soft mud where they lay on the bottom. Let's see what else we've got right here. That is covered up with just enough muck that you can't really tell what it is. The more you look over here, the more of these fossil fragments you find all over the place. So it's just loaded with shells. Now have a look at this guy. He actually looks quite a lot like our Mucrospirifer, but it's not quite so dramatically misshapen. It's not nearly so squat and wide as the other one, but it is still a little bit wide, and it still has points that come out at the ends. So this is a similar species of brachiopod, but different. It is a Spinocertia. Spinocertia has a little bit of a broader age range than the Mucrospirifer. It extends from the Middle Devonian to the Late Devonian. It used to be considered to be in the same family as the Mucrospirifer, alongside dozens of other similarly named spirifer species. My understanding is that they lived in a very similar lifestyle to the Mucrospirifer, and similar environment, obviously, because we're finding them right next to each other. So basically, they were neighbors that were very similar looking and very similar behaving, but just a very slightly different body shape. Oh, getting away from our shells a little bit. Well, isn't this interesting here? I don't know if I can get the camera to look the right way here. I thought maybe the lumpy texture was stromatoporoid, although now that I'm looking at it, this is definitely a Bryozoan variety. But look at that. You have a shell fragment pressed right up against it. You can identify this right away as a Bryozoan from the zoatia, these tiny pinprick holes that the moss animals, these so-called moss animals, lived in. This is not a fan-shaped bryozoan, this is a branching bryozoan. And look at all these nodules on here, look at all these lumps. That should make it very easy to identify the species. However, I'm not a paleontologist, and my guidebooks don't have any species that look like this. And so, it will be easy to identify for somebody else. All I can really say is that what we have here is a branching bryozoan. Let's see, what else are we finding over here? This is all, you notice I'm not moving here. I just found a nice patch with a lot of stuff. Oh, hey ho. This brachiopod appears to be a Rhipidomala. Everything about this fossil screams Rhipidomala to me, except for the body shape, which you would think would be really important. The shape of this piece, you notice the shell tapers down to a point at the hinge, at the base. On Rhipidomala, it tends to be a bit more rounded out with a flatter base. But because everything else seems to match up so nicely, and because Rhipidomala is one of the most widespread brachiopod varieties in the Middle Devonian where we are, I'm going to say it's probably Rhipidomala, or at least a very closely related species. Rhipidomala appears to be a very adaptable species. It's found in all sorts of sediments. So it's found in soft calcareous muds, and it's found in sandy areas. It could kind of adapt to live pretty much wherever it needed to. Oh, what we got here? That's an interesting one. Oh geez, and now we arrive at this piece. This is a gorgeous piece. Have a look at this. I mean, those ridges that run the length of the body from the hinge up to the point, they're so distinctive, they're so dramatic. In fact, you can even see some points at the end that probably resulted in spines, which are common on a lot of these animals. I took it home with me and I said, well, this is so distinctive, this should be very easy to identify. And then I started looking into it and looking and looking and looking, and I couldn't come up with anything. And I said, this is too distinctive. How can I not be coming up with results for this? It's certainly not in any of my guidebooks. I can't find any information online. Heck, I even took it to AI and did an image search on it and said, hey, AI, can you tell me what kind of fossil it is? They said, hey, this is a stromatoporoid. I said, all right, well, I should have known better than to ask AI. So I took it to something better than artificial intelligence. I brought it to real intelligence, not in person, but I shared a series of detailed photos with a friend of mine that works at a major university running their museum. And this guy is a paleontologist, a true paleontologist, not a layperson, not a geologist who doesn't do paleontology, but a true biologist / paleontologist who runs a fossil museum at a university. And his answer was, I don't know. He suggested to me that I might be barking up the wrong tree by calling it a brachiopod, that this is more likely a bivalve. I'm not 100% sure what he's going off of on that, but this is a guy who studies shells for a living, so I'm going to trust him. But what species is this? Even what class within bivalve? I just don't know. If there are any paleontologists out there watching this and you recognize this guy, let me know in the comments, please. I would love to find out what this is. It's sitting on my desk right now, unidentified. Okay, this guy is definitely a Rhipidomala, I think. But compare it to the last piece I called a Rhipidomala. See the different shape of the shells? Doesn't that make you uncomfortable calling them the same species? I know it does for me. This one is probably more likely to be a true Rhipidomala, whereas the other one is more likely to be a closely related species. Now this brachiopod could definitely be Devonoconides. Now, I mentioned Devonoconides earlier in reference to a Strophomana. You can see the different size and general shape of the shells. You can see they're very similar when I put this comparison up, but they are not the same. And I think this smaller piece I've got here is a Devonoconides. It is a brachiopod, and it basically lived the same lifestyle as most of these other guys that we've seen. Sitting loosely on the seafloor, which would make sense here since we are on a sandy shoreline here. And it had spines that it would use to stabilize itself on the seafloor. Let's move along and, travel a few inches at least. But to travel those few inches with me, you're gonna have to join me next episode. So join me next time as we explore more of this ancient island and then move back down into the coral reefs and learn more about those ecosystems 390 million years ago.